All right, this is Dr. Matthew J. Traum from Engineer Inc. And the purpose of this video is just to give you guys an update to show you one of the projects that I've been working on for my fluid mechanics course. This is a volume flow metering experiment. And to give you a sense of what we're doing here, we're essentially looking at 3 different instruments that measure volume flow rate, calculating the volume flow rates that they give us, and then determining within experimental uncertainty how well those volume flow rates agree with each other. So what I've essentially done is taken a experiment from a university that I used to work at that was the size of a large classroom. It took up about a whole wall of a laboratory space, and I've shrunk it down to something that essentially fits on a student's desktop and costs somewhere on the order of about $30 for all these components. So pretty affordable even for an undergraduate student on a budget. And a lot of these components get reused for other laboratories. There'll be 15 laboratory exercises in all. So the total cost of this kit will be on the order of $200, so less than a new fluid mechanics textbook. And what this will allow is for students to take a fluid mechanics course online that has these integrated take-home, hands-on, applied laboratory experiments where students will collect, analyze data, and write lab reports. And that will allow them to take an online fluid mechanics course that has laboratories and achieve the ABET outcomes for accreditation associated typically with a brick and mortar course at a university that has an integrated laboratory component. So that's where we're going here. Anyway, what I've done, I've got a pump here, and this pump draws water from this liquid reservoir, and the pump is attached to a pulse width modulator right there. So that allows me to control the volume flow rate, and I can set the volume flow rate really anywhere that I want. When we run the experiment for real, we'll probably use 3 different volume flow rates and compare the accuracy of each of these instruments with those 3 different volume flow rates. But for now, I'm just going to show you one volume flow rate just to give you a sense of what I'm doing. So the water gets pushed through this pump, again at variable volume flow rate, but we're going to just use one for this experiment. And then it runs through this RainWave meter. This is a volume accumulation meter that measures in liters. I can get as small as 1/10 of a liter resolution, and this is actually used for gardeners, so people who are worried about overwatering their plants. So this would attach to a hose, and people in the garden would figure out how much water they're putting on their plants. So it's going to measure accumulated volume. And then here I've just got an old iPhone that's just going to serve as a stopwatch. I could use a $2 stopwatch if I wanted for this purpose, but I have the iPhone handy, so it's just going to be a timer. So the combination of accumulated volume and time is going to give me volume per second, which is the volume flow rate. So that's one measurement. The second measurement instrument here is a Rotameter. So the Rotameter is going to give me a second measure of volume flow rate. You can see there it measures in gallons per minute and liters per minute. So I'll be able to determine the liters per minute directly from that measurement. And then the water comes out of the Rotameter and goes back into the reservoir. However, there is a third measurement instrument here, which is an O-house balance, and it's got a little reservoir on top. And so what I'll do once the fluid is moving in a steady state situation and I've taken my other measurements is I'll take the water hose that's dumping water back into the reservoir, and I will put it over here so that the water begins to accumulate in the reservoir, and we will get a mass change with respect to time. The mass change with respect to time is going to be monitored here on my laptop computer using the terminal program. And just as a quick aside here, of course, I've got K.C. Madden, the world's greatest helicopter pilot, on my desktop. That's the fellow who rescued all those guys off Mount Everest, set a world record for elevation for helicopter flight before it was possible to just easily land on top of Mount Everest due to new technology. So this guy is my hero. Anyway, so we're going to use the terminal program to calculate the mass per unit time. And if we know the mass per unit time and we know the density of the water, which I determined from the temperature, which I measured earlier, we'll be able to get volume flow rate. So 3 different ways of measuring volume flow rate, from mass accumulation, direct volume flow rate, and then from volume accumulation, using a pump that can be set at 3 different volume flow rates. So let me give you a sense of how this might work. So let me plug this in. Okay, you heard the pump kick on, so I can move over here to the Rotameter, and you can see I can change the volume flow rate, and the Rotameter float will change in response to the volume flow rate. So I'm just going to set this at the highest value measurable so that the experiment will go quickly. So there we have it, about 2 liters per minute running through my system. So that's a good steady value. And then I'm going to come over here and notice that the rain gauge meter is accumulating volume. And what I want to do is start the time when I tick over to the next value of another 1/10 of a liter. So when it hits 2.3, I'll start the time and I'll let it run. Oops, our friends at Apple want us to connect to iCloud. So we'll cancel out of that. Just let the time keep running. So again, I'm accumulating volume and I'm timing it. So let this go a little bit further. We're going to get several data points out of this. Okay, that's probably good enough. So we'll stop that. So I've got a video record of that, so I've got a data record there. I'm now going to zero my balance, and I'm going to grab this hose, which is returning water to the reservoir. And, oops, I skipped an important step, which is to start data logging. So let's start data logging here. Boop, boop. Okay, and we can see there that we are actually logging data. There it is. Okay, back to the balance, which is still zeroed. So now I'm going to grab this water, and this is going to make a little bit of a mess, but not too bad. And I'm going to move the water boop, over here. And be very careful that the hose isn't actually touching the scale, because that would ruin my measurement. And this thing will max out at 400 grams. There it is. So I'm going to move this back. And having now collected all the data over here, I can stop logging. Cool. Okay. And that is effectively the end of the experiment. Now let me just check here at the Rotameter that I'm still reading 2 liters per minute, which I am. And now let me just turn off the pump. Okay. And that's the end of at least one phase of data collection. I'll do the calculations and let you know the results. Thanks for watching. Bye.